All right, so Chemistry 2, Chapter 11, Molecular Composition of Gases. So we are still on gases. Part 1 is volume to mass relationship of gases. So as always, I highly suggest you taking notes and actually trying the practice problems. The beauty of the video is you can pause and rewind and work at your own pace. So we first need to talk about Avogadro's law. His law basically says equal volumes of gases at the same temperature and pressure contain equal numbers of molecules. So if you look at the image depicted here, you have hydrogen gas, oxygen gas, and carbon dioxide gas. Okay, and they're just representing what each molecule looks like. Okay, 1 mole of hydrogen gas. Okay, 1 mole is equal to Avogadro's number. 1 mole of oxygen gas, 1 mole of carbon dioxide gas, all at the same pressure. Okay, so that's just kind of getting us ready to talk about the relationship between gases. So recall, as I just said, 1 mole is equal to Avogadro's number, 6.02, times 10 to the 23rd molecules or atoms. That's Avogadro's number. You don't necessarily need to write this down, just listen and look at the picture. It says 22.4 liters, which is standard volume, of each gas contains the same number of molecules, but the mass is going to differ. The mass of each is equal to the molar mass of the gas. So we know that some molecules are heavier than others. However, they still have the same number of molecules present. And the mass is equal to 1 mole. Okay, so you can see that we have oxygen gas versus hydrogen gas. Oxygen is obviously a bigger molecule, mass of 32 grams. The mass of hydrogen is only about 2 grams per molecule per atom. Hydrogen obviously has less mass, but it does have the same volume. So if we're saying 1 mole of oxygen, you really have to remember your diatomic elements, okay? So if you don't remember those, just always consult your periodic table where it should be written down. So we have 6.02 times 10 to the 23rd molecules or atoms is equaling 1 mole of oxygen. 1 mole of oxygen equals the molar mass of oxygen. So we have 16 plus 16, 2 oxygens, gives us 32 grams. Okay, so once again, 1 mole is always equivalent to this number of molecules, 6.02 times 10 to the 23rd, and 1 mole of oxygen is also equal to 32 grams of oxygen. If you have 1 mole of hydrogen, 1 mole is equal to Avogadro's number. 1 mole of hydrogen is also equal to 2.02 grams of hydrogen. We have 2 hydrogen, 1.01 plus 1.01 gives us 2.02. So what about 1 mole of helium? Okay, try to figure this one out. Pause the video, try it out. 1 mole of helium is going to equal how many molecules and how many grams? So just consult your periodic table. Okay, so let me get my black pen. 1 mole of helium is going to equal, once again, 6.02 times 10 to the 23rd molecules, Avogadro's number. And then helium is not diatomic. So look at my periodic table, and the atomic mass for helium is about 4. So 1 mole of helium is equal to Avogadro's number, and 1 mole of helium is also equal to 4 grams of helium, the atomic mass of He. So once again, just stating it in a different way, 1 mole of gas will equal or occupy the same volume as 1 mole of any other gas, as long as the temperature and the pressure are constant, no matter that difference in mass. So the volume occupied by 1 mole of gas at STP, standard temperature and standard pressure, where standard temperature is 0 degrees Celsius to 73 Kelvin and standard pressure is 1 atm, is known as the standard molar volume of gas, or the standard volume of gas. We didn't talk about this a lot in the last chapter because we were more concerned about standard temperature and pressure, but this is your standard volume. 22.4 liters is standard volume. Okay, so a conversion factor you have to know. You should already know the bottom one. 1 liter is equal to 1,000 milliliters. You also need to know how to convert between moles and liters. 1 mole is equal to the standard volume of 22.4 liters. So now that we can know those conversions, we can actually start our calculations. Okay, so you definitely have to know this for sure, and hopefully you already know the bottom one. Okay, so example number 1, write it down, pause the video, and then we can work through this together. So what volume in liters is occupied by 2.176 grams of gaseous oxygen at standard temperature and pressure? Remember that 1 mole is equal to 22.4 liters. Also remember that standard volume is 22.4, I just said that, sorry. Standard temperature and pressure, you should know. And please keep in mind that oxygen is diatomic, so that's why I have it as O2. If you forget it's diatomic, it's going to throw you off every time. Okay, so there's 2 steps. We need to go to volume from grams. We know that 1 mole is equal to 22.4 liters. So the first step is going to be to convert from grams to moles. So remember, to convert from grams to moles, you just divide by the molar mass of the element, or the atom, or the molecule. And then the second step will be to convert from moles to liters. Okay, so step 1. I take the number given to me. Okay, I take that, and I'm talking about oxygen, and I need to know what volume. So 2.176 grams of O2. You need a unit in the label again. And I want to convert to moles. So I'm going to put 1 mole on the top of O2 because I'm going from grams to moles of oxygen. And the bottom is going to be the molar mass of oxygen. So look at my periodic table. 1 oxygen is about 16. So 16 plus 16 is 32. It's okay if this bottom number is a little bit different than mine, depending on your rounding. Okay, so I'm converting from grams of oxygen to moles of oxygen. So throw that in your calculator, and I get about 0.068 moles of oxygen. Try not to round this number too much. Okay, going to 0.7, it'll be okay, but try to not overround it since it's such a small number. Okay, now that we know moles, we need to figure out how many liters. So now you need to use this conversion. 1 mole is equal to 22.4 liters. So I take the number I just solved for, and you can always just continue this. You don't have to separate it into 2 steps, but to show you what we're doing, I'm going to. Okay, so I took the number I just solved for. Now I'm going to use this conversion factor. So moles has to cancel out moles. So 1 mole has to go on the bottom. That's just from right here. And then I take the 22.4 liters and put it on the top. So when I solve, my moles of oxygen will cancel moles of oxygen. I'll be left with liters of oxygen, and that's what I'm solving for. So plug that into your calculator. 0.068 times 22.4 divided by 1, and I get 1.52 liters of oxygen. Round to 2 decimals if you can. So that is my final answer. 2.176 grams of oxygen is equal to 0.068 moles of oxygen, which is finally equal to 1.52 liters of oxygen. We converted from grams to liters, mass to volume. Okay, let's try another one. So pause the video, actually try it yourself. You can't know if you're good at it unless you try it. So what volume in liters is occupied by 198.24 grams of gaseous nitrogen at standard temperature and pressure? Remember, N2 because nitrogen is diatomic. So once again, we're going to go from grams to moles. So I take the number given to me in the problem. Don't forget your labels. Okay, so that came from right here. I have to convert to moles, so 1 mole is going to go on the top always. That's our constant. The bottom is the molar mass of N2. So if you look at your periodic table, 1 nitrogen is about 14, so 14 plus 14, so I have N2, is about 28. You don't have to round if you don't want to. If you are rounding, make sure you're rounding appropriately. Okay, so grams to moles of nitrogen. So 198.24 times 1 divided by 28, and I get 7.08 moles of N2. Now that I'm in moles of N2, I can use conversion moles to liters. You can do this in one step. You don't have to split it up if you don't want to. So I'm taking the number I just solved for, and I'm going to use the conversion factor, 1 mole on top, because that's what I'm going to, 22.4 liters on the bottom. Whoops, that is wrong. Sorry, guys. I'm not paying attention to what I'm doing. Try that again. 22.4 liters on the top because I'm going to liters. 1 mole on the bottom. And that's just from this conversion up here. So moles cancels moles. I'm left with liters. That's what I'm solving for. So 7.08 times 22.4 divided by 1. And I get 158.59 liters of nitrogen. If you round it up to 159, I won't be mad. If you round it to 158.6, okay. But as I always say, try not to overround 2 decimal places to keep you from overrounding. Okay? So what happens if we want to calculate mass from molar volume? Okay, so we're kind of going backwards now. I'm going to give you liters. I'm going to ask you to find the mass, either in grams or moles. Okay, so determine the mass in moles of 14.1 liter of gaseous hydrogen. Okay, so I'm using the only number that's been given to me. Once again, 2 steps. Now we're going to convert from liters to moles. So I take that number, and then I'm using this conversion. So I'm going 2 moles. So 1 mole is going to be on the top now. 22.4 is on the bottom. Liters cancels out liters. So I have 14.1 times 1 divided by 22.4, and I get 0.63 moles of H2. And I can actually stop there because I'm in moles. And I'm asking to find moles. Okay, so I went from liters to moles. Let's go a little bit complex now. Okay, so pause the video, copy this down, see if you can start it. If not, I'll work it through with you. So determine the mass in grams from 550 cubic centimeters of neon gas at STP. Okay, the first thing you need to know is that 1 cubic centimeter is equal to 1 milliliter. And then you need to know that 1,000 milliliters is equal to 1 liter. Okay, so that was from last chapter. So the first thing I have to do is convert centimeters cubed, cubic centimeters, to milliliters to liters, because I need to be in liters to begin. Okay, so I have 550 cubic centimeters of neon, which is just Ne, not diatomic. 1 milliliter is equal to 1 cubic centimeter. I know it's easy math, but show it. So now I'm 550 milliliters. I forgot my units or my labels. How dare I? Okay, now I can go from milliliters to liters. So 1 liter, let me put my labels in here like I'm supposed to be doing. Good habit. Okay, I'm just using that conversion factor. I know you can probably do it in your head, but for now, show it. Okay, so 550 milliliters times 1 liter divided by 1,000 milliliters, and you should get 0.55 liters of Ne. So now I can actually start the problem. Now I can convert from liters to moles. So I take the number I just solved for. I use my moles to liters conversion factor. And if you're confused at all, guys, you need to speak up. Chat me, come to office hours, something. Help yourself. Okay, so 0.55 times 1 divided by 22.4. I get 0.0246 moles of Ne. And yes, I'm going to give all decimals because I don't want to overround until the end. Okay, so now I'm in moles. I went from liters to moles. But the question asked me for grams. So last step, I have to go from moles to grams. Okay, so 0.0246 moles of Ne. Now I'm going to multiply by the molar mass or atomic mass of Ne. So look at your periodic table. There's only one neon here, so it's about 20.18 grams of neon divided by 1 mole of neon. Mole cancels mole. 0.0246 times 20.18 divided by 1 mole. I get my final answer to be 0.496 grams of Ne. Okay, so that's about as complex as I can get. And if you gave me 0.5, that's fine. Your number is going to be a little bit different depending on the mass that you use and how you round it. This is about as complicated as a problem I can get. I had to go from cubic centimeters to milliliters, milliliters to liters. Okay, you couldn't even start the actual point of the chapter yet. Now I'm having you go from liters to moles, and then moles to grams. As complex as I can get. Okay, so let's try one more. Try this one. A chemical reaction produced 98 milliliters of sulfur dioxide gas, which is SO2. If I didn't give you sulfur dioxide, remember that's a prefix, so it's just S, 1 sulfur, di, 2 oxygen. No checking of charges at all for this. What is the mass in grams of gas produced? So what's the first thing you have to do? You have to go from milliliters to liters. 1,000 milliliters equals 1 liter. Okay, I know you can do this in your head, but if I ask you to show the work, make sure you do so you get full credit. If I don't ask you to show the work, it's not necessary. Okay, so now I'm in liters. Okay, The second step is to go from liters to moles. 22.4 liters equals 1 mole. One mole on top, because that's what I'm going to. 22.4 liters on the bottom. So I take 0.098 times 1 divided by 22, and I get 0.0044. Like I said, I'm not trying to over-round yet. If you cut it off to 0.004 or 0.004, okay. Try not to round over too much. Okay? And my last step, I need to go from moles to grams because it asked me for my answer in grams. Okay, so I take moles that I solved for. Whoops. I don't know what I just did. Hold on. Sorry about that. I zoomed in. I didn't even know it. Okay, let me write over here. 0.0044 moles of SO2. I need to have the molar mass of SO2 on the top, 1 mole of SO2 on the bottom. So how do I find the molar mass of SO2? Well, I know that sulfur is about 32 grams, looking at my periodic table, so 32, and oxygen's about 16, and I have 2 of them. So 32 plus 16 plus 16 gives you about 64. Just molar mass. Do you know how to do that? You've been doing that forever. Okay, so 0.0044 times 64 divided by 1. My final answer is 0.28 grams of SO2. I went from milliliters to liters, liters to moles, moles to grams. If you are at all confused, especially when you get to the worksheet, please ask for help. Chat me or Zoom with me. That is the point of the office hours, to help you live, since I'm not teaching you live on a daily basis. And if you don't actually try these problems, you're not helping yourself, guys, okay? You would try them in class, at least somewhat. Do them now. It will help you, I promise. So that is the volume mass relationship of gases, going from moles to liters of a gas, liters to moles of a gas, or considering grams in there. Part 1 of chapter 11.